The radian is the standard unit of angular measure, used in many areas of mathematics. An angle's measurement in radians is numerically equal to the length of a corresponding arc of a unit circle, so 1 radian is just under 57.3 degrees. The unit was formerly an SI supplementary unit, but this category was abolished in 1995 and the radian is now considered an SI derived unit. The SI unit of solid angle measurement is the steradian. The radian is represented by the symbol rad. An alternative symbol is the superscript letter C, for circular measure euro, but this is infrequently used as it can be easily mistaken for a degree symbol. So for example, a value of 1.2 radians could be written as 1.2 radians, 1.2 radians, or 1.2 C. Definition: radian describes the plane angle subtended by a circular arc as the length of the arc divided by the radius of the arc. 1 radian is the angle subtended at the center of a circle by an arc that is equal in length to the radius of the circle. More generally, the magnitude in radians of such a subtended angle is equal to the ratio of the arc length to the radius of the circle. That is, I equals S/R, where I is the subtended angle in radians, S is arc length, and R is radius. Conversely, the length of the enclosed arc is equal to the radius multiplied by the magnitude of the angle in radians. That is, S equals R. As the ratio of two lengths, the radian is a pure number that needs no unit symbol, and in mathematical writing the symbol rad is almost always omitted. When quantifying an angle in the absence of any symbol, radians are assumed, and when degrees are meant the symbol a degree is used. It follows that the magnitude in radians of one complete revolution is the length of the entire circumference divided by the radius, or 2I euro r/r, or 2I euro. Thus 2I euro radians is equal to 360 degrees, meaning that 1 radian is equal to 180/I euro degrees. History: the concept of radian measure, as opposed to the degree of an angle, is normally credited to Roger Coates in 1714. He described the radian in everything but name, and he recognized its naturalness as a unit of angular measure. The idea of measuring angles by the length of the arc was already in use by other mathematicians. For example, Al-Kashi used so-called diameter parts as units where one diameter part was 1/60th radian, and they also used sexagesimal subunits of the diameter part. The term radian first appeared in print on June 5, 1873, in examination questions set by James Thompson at Queen's College, Belfast. He had used the term as early as 1871, while in 1869, Thomas Muir, then at the University of St Andrews, vacillated between the terms rad, radial, and radian. In 1874, Muir adopted radian after a consultation with James Thompson. Conversion between radians and degrees. As stated, 1 radian is equal to 180/I euro degrees. Thus, to convert from radians to degrees, multiply by 180/I euro. For example. Conversely, to convert from degrees to radians, multiply by I euro/180. For example. Radians can be converted to turns by dividing the number of radians by 2I euro. Radian to degree conversion derivation: the length of circumference of a circle is given by, where is the radius of the circle. So the following equivalent relation is true, since a sweep is needed to draw a full circle, by the definition of radian, a full circle represents. Combining both the above relations. Conversion between radians and grads: radians are equal to 1 turn, which is by definition 400 grads. So, to convert from radians to grads multiply by, and to convert from grads to radians multiply by. For example. Conversion of some common angles: the table shows the conversion of some common angles. Advantages of measuring in radians. In calculus and most other branches of mathematics beyond practical geometry, angles are universally measured in radians. This is because radians have a mathematical naturalness that leads to a more elegant formulation of a number of important results. Most notably, results in analysis involving trigonometric functions are simple and elegant when the function's arguments are expressed in radians. For example, the use of radians leads to the simple limit formula, which is the basis of many other identities in mathematics, including. Because of these and other properties, the trigonometric functions appear in solutions to mathematical problems that are not obviously related to the function's geometrical meanings. In all such cases it is found that the arguments to the functions are most naturally written in the form that corresponds, in geometrical contexts, to the radian measurement of angles. The trigonometric functions also have simple and elegant series expansions when radians are used. For example, the following Taylor series for Scheiner-Zahm. If x were expressed in degrees, then the series would contain messy factors involving powers of I/180. If x is the number of degrees, the number of radians is y equals I/x/180, so. Mathematically important relationships between the sine and cosine functions and the exponential function are, again, elegant when the function's arguments are in radians and messy otherwise. Dimensional analysis. Although the radian is a unit of measure, it is a dimensionless quantity. This can be seen from the definition given earlier: the angle subtended at the center of a circle, measured in radians, is equal to the ratio of the length of the enclosed arc to the length of the circle's radius. Since the units of measurement cancel, this ratio is dimensionless. Although polar and spherical coordinates use radians to describe coordinates in 2 and 3 dimensions, the unit is derived from the radius coordinate, so the angle measure is still dimensionless. Use in physics. The radian is widely used in physics when angular measurements are required. For example, angular velocity is typically measured in radians per second. 1 revolution per second is equal to 2 radians per second. Similarly, angular acceleration is often measured in radians per second per second. For the purpose of dimensional analysis, the units are ZAR1 and ZAR2 respectively. Likewise, the phase difference of 2 waves can also be measured in radians. For example, if the phase difference of 2 waves is radians, where k is an integer, they are considered in phase, whilst if the phase difference of 2 waves is, where k is an integer, they are considered in antiphase. Multiples of radian units, metric prefixes have limited use with radians, and none in mathematics. A milliradian is a thousandth of a radian and a microradian is a millionth of a radian, that is 103 mrad equals 106 urad equals 1 radian. There are 2 1000 milliradians in a circle. So a trigonometric milliradian is just under 1/6283 of a circle. This Euro trigonometric unit of angular measurement of a circle is in use by telescopic sight manufacturers using range finding and reticles. The divergence of laser beams is also usually measured in milliradians. An approximation of the trigonometric milliradian, known as the mill, is used by NATO and other military organizations in gunnery and targeting. Each angular mill represents 1/6400 of a circle and is 1% smaller than the trigonometric milliradian. For the small angles typically found in targeting work, the convenience of using the number 6400 in calculation outweighs the small mathematical errors it introduces. In the past, other gunnery systems have used different approximations to 1 or 2000 euro. For example, Sweden used the 1/6300 streck and the USSR used 1/6000. Being based on the milliradian, the NATO mill subtends roughly 1 m at a range of 1000 m. Smaller units like microradians and nanoradians are used in astronomy, and can also be used to measure the beam quality of lasers with ultra-low divergence. More common is arc second, which is Euro 648,000 radians. Similarly, the prefixes smaller than milli are potentially useful in measuring extremely small angles. See also, angular frequency, angular mill, military measurement, grad, harmonic analysis, steradian, the square radian, trigonometry, notes and references. External links, Radian at MathWorld.